Hi, welcome to Halloween. Obviously, I don't normally dress like a doctor, but I play one on TV. We're going to talk through imaginary numbers learning card today. And so let me zoom in here. I have the links to all of these down below, or at least I will be. I'll try to get it all in one folder and I'll try to organize it with a spreadsheet in a bit. But I'm going to zoom in a touch here. So for imaginary numbers and complex numbers, remember an imaginary number starts off with it's the number squared that gives me -1. So that means that I is going to equal the square root of -1. Okay? From there, a couple of things to simplify it. If I have the square root of a negative, let's say 25, I'm going to break that into the square root of 25 times the square root of -1, because the -1 is the only real problem. The square root of 25 we know is 5. So this is going to equal 5. And then the square root of -1 is going to turn into the I. So if you pull out the negative, you can always stick an I on the end of it. Complex numbers is always going to equal a real component plus an imaginary component. So as an example, you would have, let's say, 3 minus 4i. The real part comes first. The imaginary part comes second. If you look at the video I did on imaginary numbers, the thing to remember is that imaginary numbers aren't necessarily not imaginary. They just are a opposite type or a different type of related number to reals. They're used in electrical engineering and things like that. So about multiplying, some things to remember here. When you're multiplying numbers, simplify your roots first. So if I have the square root of -16 times the square root of -25, it'll be really easy to go through and say, okay, that's the square root of 400. So you get 20. But the thing is to remember, 400 has an actual, the square root of that's 20. It's not anything special. So here, I'm going to simplify this down to 4i. The square root of 16 is 4. Square root of -1 is I. Times, I'm going to do the same thing here. I'm going to get 5 times I. So that's going to equal a total of 20i squared. From there, that's going to be 20 times -1, which gives me -20. Okay, so you need to simplify it first. For division, remember I is a radical, which means we must rationalize it. We'll do an example of a little bit more complicated one over on the right. But if I had 6 over, let's say, 5i, I would need to multiply this by I over I to get rid of the I in the denominator. So I'm going to get 6i over 5i squared, 6i, 5 times -1. And again, this is more steps than you need. I'm writing this down just so you can see when you look at this back and you look back at it, you can say, oh yeah, he did this, 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 and this. So there's not so much less. Okay, so that's the basics. So now we're going to go through 4 examples over here. Obviously, pause and rewind as you need to. When you subtract and add, it's going to be just like polynomials, like terms to like terms. So in this case, we are going to make sure that you're going to just go through. I'm going to do real numbers to real numbers, imaginary to imaginary. So this negative would go here. So this is going to be the same thing as 5 plus 3i plus 9 plus 5i. So 5 plus 9, 14. 3 plus 3i plus 5i is 8i. And that's it. Okay? So just like if it was an x. The same thing is going to hold true for number 2. If you want to go through and you know the binomial squaring issue, squaring shortcuts, please go ahead and do that. If you would rather write them out side by side, also perfectly fine. So up over here, three times 3 will get me 9. -5i times -5i is going to end up being 25i squared. The I squared, remember, is going to be -1. So this is really equal to a -25. And that's going to be a little side note we're going to do here in a second. This is negative 15i. This is a negative 15i. So notice this is going to turn into 30i. And then this top part here is a negative 16. So your answer is going to be negative 16 plus 30i. Now, what I was saying is one thing, and you may want to put this on the back, do this in some separate notes. You should never have I to a power of 2 or more. And the reason being is because if I have I squared, that's negative 1. So if I have I to the negative third, that's just I squared times I, which is negative 1i, or you could read it as the opposite of I. If I have I to the fourth, I can break that into I squared and I squared, which is negative 1 squared, which is 1. And then I to the fifth would just start the process all over again because I would be up here, right? Then I to the fifth would be I to the fourth times I. And that's just going to equal I. Okay, I've got another video I can link to that if you want to see more on that. So, in terms of the other two parts down here, multiplying here, similar to what we did up above. And again, you could have used a shortcut for the squaring things. So again, I'm going to get 15 for this one. This part here is going to turn into positive 14i squared, which is really a negative 14. In the bottom, negative 10i, negative 21i. It's a little sloppy, my apologies. So this up here is equal to 1. So my final answer would be 1 minus 31i. Because again, remember, this squared part up here, okay, that's going to equal negative 1. And then when I'm dividing, it's just like when we had, if you remember back once upon a time we did something. If this was, let's say, 9 minus 5 square root of 5 times 3 plus root 2, you'd have to multiply through by the conjugate to try to get rid of the root of the bottom. The same thing is going to hold true here. So for this, I'm going to multiply this by the conjugate is 3 minus 2i. It's always going to be the opposite sign of what's in the denominator. So since I have 3 plus 2i, I'm going to multiply by 3 minus 2i. If it was minus, I would multiply by a plus. And the reason being is when I multiply these two parts together, I'm going to get a zero pair. I'm going to get 6i and negative 6i, which cancel each other out, as some of you like to say. So when I multiply this out, this denominator is going to turn into 9 minus 4i squared. Okay. The top is going to turn into, I'm going to get a 27. I'm going to get a plus 10i squared. I'm going to get a minus 15i and a minus 18i. And then from there, we're just going to simplify. This is negative 10. This is negative 4. So now you're subtracting a negative. That's going to turn into like adding. So this denominator is going to turn into 13. And on the top, I'm going to end up getting 27 minus 10, which is 17. And then negative 15i minus 18i, which is going to be a negative 33i. And then I don't have the I in the middle. Okay? So obviously, a lot of stuff there. This is intended to obviously be after you've already learned it and kind of summarize things. Link down below. Obviously, like, comment, subscribe, and all that other good stuff. And I'll see you the next time. Catch you later.